Hi, we have a question in 3.4, question number 36, graphing piecewise defined functions. Actually, I did this in, I know a couple of my classes, at least exact same problem, but I'll do it again. And, but, it's a function. It's 1 over x when x is less than 0, and it's the cube root of x if x is greater than or equal to 0. And now, recall that these two functions are part of your library of functions, and I put it right here. F of x equals 1 over x, that's a reciprocal function, and it looks something like this. I call it the wicked butterfly. Um, Probably the more mathematical correct name is the hyperbola. And this is the cube root of x, and plotted a few points, and it has a little S shape. So now, believe it or not, what you're doing, if you can work Photoshop, you should be able to do this. If you're able to crop something and take something out and move it and actually maybe make two pictures into one, you should be really good at this as well. Because the reciprocal function in my answer here only going to be defined for x is less than 0. So what you're going to do is you're going to crop off anything on the right side of that. So you only got basically the left wing here. So the function is only going to be defined on the left side to be 1 over x. So here is x equals 0. But on the left side of that, it's going to be defined as 1 over x. And on the right side of that, it's the cube root of x. So this is how I kind of keep tabs of where I'm at. Now, so it's 1 over x on this side, which is this part right here of the graph. So I'll put that on here. So I'm just going to copy and paste it over here. Now I'm not going to do the right wing of it because it's only going to be this part on the less than x is less than 0. Now the cube root of x is this little S shape, and it's defined on the right side. So you're going to crop off the left side of the S and only keep the right side of the S in this case. So it looks like this. So this piece is taking this piece, and I cropped this off, took this part, and put it here. And then this part, cropped this off, took this part, copied it over here. So this is very important. A lot of people don't believe this is important. This is important because that tells you what part you're going to keep and what part you're going to crop of the library of the function that is in the library. So on the less than 0 is just a 1 over x. So that's what we have right there. Now I just got to make sure I got the dots in the right place. And this does include it because it says greater or equal to 0. So that's the way it should be. So that's the graph. So that's actually the answer to part C. Now, to part A and B and D, I think A is looking for the domain, and the domain is basically the x's. So you just kind of scan through here. Where do the x's start? Oh, the left arrow means it's negative infinity. So you keep scanning. So all these x's are defined. Probably the only point in question is 0 because obviously it's to the right of 0. But it is defined as 0 as well because there's a dot right there at the origin. So all x's are accounted for. This actually gets closer and closer and closer, so it takes account of all of them. So the domain is negative infinity to infinity. Okay. Now the intercepts is where they cross the x-axis and where it crosses the y-axis. I kind of do it by observation in this case because the only x-intercept I have and the only y-intercept I have is at the origin. So the x-intercept, the y-intercept are both. And that's not the case every particular problem. It's only when it's going to cross at the origin. But in this case, the intercept is at the origin. Now, the last part D, because part C is, like I said, is the graph. There is a range, so can you look at their y-coordinates and see what y-coordinates are out there? Well, y-coordinates is up and down. So it's negative infinity, comes up almost to 0. Does 0 get included? Yes, because there's a dot right there, and then it goes up, but gradually. It does go up, though, but it does go up gradually. Eventually, it keeps going up and up and up. There's no asymptote here, if you will. So, and what it is just a slow, gradual rise. But all y-coordinates are accounted for as well. So the range is also negative infinity to infinity. So, and you probably can't get the range unless you draw the graphs. If you don't get C right, you're probably going to miss D as well. So because D depends on whether you're going to get C the graph correct or not. So, but anyway, this is problem number 36 in section 3.4.